All right, good day, everyone. Today what we're going to be talking about is arithmetic series, okay? And the key thing I want you to understand with this is there's got to be two different steps with our arithmetic sequences versus our series, okay? Yesterday we talked about how specifically in a sequence, our goal is to basically find that value that we really wouldn't want to count to, okay? For example, in this one, if I wanted to find a of 15, okay, well, just let me make sure my pen works. Takes a minute. Sorry about that. There it goes. If I wanted to find a of 15, I could do this one of two ways. I could either count till I get to that 15th number, which is kind of a hassle, especially the bigger the value you're looking for, or I could use my actual equation. Yesterday, we talked about basically how we could use our equations to understand that as long as we have the first term and the difference and the value, or excuse me, the term number and then the difference, we could build up from that and actually get to that value a lot quicker. Okay? But the key idea we wanted to maintain was the fact that this is all just a pattern. It's a pattern of numbers. In reality, the equation itself, is almost like a shortcut to get us to that final position, right? Instead of adding 3 until I get to that 15th number, I could just plug it in and get to that value a lot easier. Well, today we're going to talk about kind of the next idea behind this, which is called a series. And the key thing you have to understand a series, or what we call a partial sum, is that we are going to be combining the values together of these pattern-based values, okay? So one of the things I want you to understand is within a partial sum, it's a total value of all of those numbers within the pattern. So if you notice on the screen right now, if I look at a value like S of 4, S of 4 says I want the sum or the partial sum of the first 4 terms. Well, if you notice, I kind of have it underlined up here. The first 4 terms are 4, 6, 8, 10. So if I want to find the partial sum of that, I would take all 4 of those values, add them together to get to 28. Okay? And I would do that for each one. If you think about S of 5 here, the answer is 40, but I got that by just taking the first 5 terms, which is 4 plus 6 plus 8 plus 10 plus 12. Okay, the first 5 numbers of that series combined together. Okay? And that's the only thing that we're really doing different within this lesson. Instead of finding a specific number within the pattern for sequences, a series is finding the total of all the numbers that are within that pattern. Okay? The only difference, or the only thing you have to think about, is that for a series, a partial sum is what we find. Okay, that's currently the thing that we are finding. We're not looking for the total of all the numbers in the pattern. We're looking at to a specific number, what is that value? Okay. Now, once again, here's the thing. We could probably sit here and add all these together, especially if we had technology. That's not really where the issue lies. The reason why this is an Algebra 2 concept, or the reason why we use this in this class particularly, is because eventually you're going to get like S of 55. And while it might seem easy to take 55 numbers and add them together to get your answer, that would be a challenge and overall a pretty big hassle. So what we're able to do is we're actually able to use an equation. That equation is listed right here. The series, or the partial sum, is equal to the term number over 2 times 2 times a of 1 plus n minus 1 times d. Okay? The key thing I want you to understand with this equation is that it's very similar to what we talked about yesterday. If you notice, this is our sequencing equation. And all we really do is implement it within our new equation. Okay? So with that being said, let's actually apply this idea. So if I want to look at this idea and actually use this formula to solve for a partial sum, in this case, they're looking for S of 20, right? I want to find the sum of the first 20 terms of this pattern. Well, to do this, I need to basically follow the same exact route or the same exact pattern that we did yesterday. I need to find a of 1, which in this case is 3. That's our first term. Our difference, which in this case is going to be a growth of 5 each time. So our difference is 5. And then our term number is what we're always looking for, which is 20. And then from there, I'm just going to fill it into the equation. If I want to find the sum of the first 20 terms, that would be equal to, oops, stylus is going out on me a little bit, 20 over 2 multiplied by 2 times a of 1, which is 3, plus n minus 1, n is 20, so we have 20 minus 1, times our difference. And now at this point, you could use technology to help simplify this. You could kind of plug this in the calculator, or you could do this by hand and say that this is going to come out to be 10, 20 divided by 2 is 6 plus 19 times 3. We could simplify the inside. This comes out to be 57. So 57 plus 6. This would be 10 times 63. And eventually you get those to come out to be a final answer of 630. Okay? So notice the process we did there. Once again, we have an equation very similar to what we talked about the first day, and we're able to plug that in to get the sum of the first 20 terms. That's what 630 represents. Okay, that is the total amount that we have over the first 30 terms if I added all those values together. Okay? We'll talk about that more in class and kind of go through more in depth. Besides that, answer any other questions on the Ed puzzle, and I will see you in class tomorrow.